Welcome to our fifth maths video on probability. In this one, we're looking at a concept called conditional probability. Okay, so our learning intentions for this video is to understand the notion of conditional probability, so what it means, and that extra information can alter probability of an event. To know how to use a Venn diagram or a two-way table to determine a conditional probability. And in this video, we're just going to look at Venn diagrams. And then to be able to identify a conditional probability scenario in a worded problem. Okay, so conditional probability. So what it's about is the likelihood of one event happening is if another already has. So when we're thinking of our subsets, it's the likelihood of subset A occurring is if B already has. So what is the probability of A happening, whatever scenario that is, if B has already occurred? So in our mathematical notation, this is how we write that. So we've got there the probability of A occurring, okay, if B has already occurred. So A occurring if B has. And how we get that is the union of A and B out of B. Okay, we'll do some examples in a minute. With our notation as well, rather than writing the probability of, that's the intersection, not union, sorry. Rather than writing the probability of the intersection, we write the value, so n meaning the number of the intersection out of the number of B. And then if we're doing the converse, the opposite, so if we're looking at B occurring, if A has already happened, we would write it that way. So that B would come first, and then again we're looking at that intersection, but now we're saying the intersection value out of A. Okay, but if it's B that's occurring after A, then B comes first, and if it's A that's occurring after A, then if it's A that's occurring after B, then A comes first. All right, let's have a think about this. So here we're looking if A is occurring and B has occurred. So basically, that's the probability of A, that whole section. However, if we're looking at this conditional probability here, what we're looking at is if A occurs, so we're only doing the section that's influenced by B, so that intersection, so the part of A that is intersected by B. So we're seeing what is the probability of A affecting what's happened in B, so that section there. Alrighty, so let's look at this. So we've got subset A in the first part of the Venn diagram. We've got subset B in the second part of the Venn diagram. We've got our intersection here, which is 3. Our union of A and B is, so add them together, 14, okay. We've got nothing outside of the union, okay, so our total value of our universal set, our total number of elements is 14. So how would we find the probability of A? Okay, so this is everything that's occurred in A. So we've got 5 plus our 3. So we've got 8 out of 14. Okay, because our total union is 14. And 5 plus 3 is 8. We can simplify that. Okay, what's the probability? What's the union? Sorry, what's in the intersect? What's the probability of a value being in the intersect? So that is 3. So there's 3 there out of our total of 14. What's the probability then of A occurring after B? Remembering that we put what's in the intersect out of B. So we'd be putting 3 out of 6. Sorry, out of B, remembering the total of B. I got that incorrect there, didn't I? 3 and 6 is 9. So the intersect, which is 3, out of the total of B, which is 9. So 3 out of 9 which we can simplify. And then what is the probability of B if A has occurred? So we've got the total of A, we've got what's in the intersect for B and A is 3 out of 8. Okay, because we're doing what's in the intersect B out of the total of A, which is 8. Cool. All right, so let's have a look at this again. We'll do another example. Okay, so our values have changed now. Our subset A here is our 7 and our 6, so 13. Subset B is 6 and 2, which is 8. And we've got 3 outside the union. So the probability of A, 13 out of 18. So our entire universal set. Okay, so 18 is that entire universal set. So what's in our intersect? Okay, so remember the intersect is between A and B, so we now forget about number 3 for a second. So we've got 6 out of the total of the union, which is 15. So we can simplify that. All right, so what's the probability of A occurring if B has already occurred? So our intersect section is 6 and our total for B is 8. So remember we're looking at the intersect out of B. So 6 out of 8. And we can simplify that. And then let's see the probability of B occurring if A has already occurred. So we've got 6 out of 13. Okay. So it's all about that, one thing occurring if something else has happened. Hope you enjoyed this video. I'll see you in the next one.